Okay, so we want to start this lesson with just basic understanding of some of the general concepts within stats and research. Hopefully some of these will be familiar to you as we would have discussed them in Foundations class. Some of these may be new, but in either case it's really important that you get these basic concepts prior to coming to the face-to-face, so as we jump in with both feet, you'll be able to kind of keep pace and move forward. So one of the first basic concepts that we want to talk about is this idea of the population. When we talk about population, we're talking about the complete set of people or objects that we want to examine or study. So for instance, let's say we had this wonderful new program that we thought would help high school seniors do better on their ACT. So the complete population for us, let's say, would be all high school seniors within the U.S. and wanting to see how this program might impact them. However, generally speaking, we don't look at or examine or study or do research on a complete population. Instead, what we want to do is take a sample or a subset of that population. It's basically pulling several individuals out of the population so that we can look at those individuals more closely and be able to say something from those individuals then to the whole population. One of the things that I want you to note is the, in parentheses, this uppercase N, and for the sample, the lowercase n. These are statistical notations that you might see in research or that at some point we'll talk about in class. Anytime you see an uppercase N by itself or a lowercase n, you know immediately that statistically speaking, we're talking about either the population or the sample. Now I will tell you, part of the challenge in quant is knowing what these symbols mean and what people are talking about when they use certain terminology. So it is helpful, and you'll notice in your text that field has a whole page or maybe 2 pages dedicated to symbols and what they are referring to. So familiarize yourself with that. Here are 2 examples, the capital N and lowercase n, that refer to population and sample. The question becomes then, why do we even take a sample? And most of you will know this intuitively, and if not, by the time you get to your dissertation, it will make a lot of sense. The reason that we want to take a sample is if we study every high school senior in the U.S., it's going to take an inordinate amount of time to do so, and probably isn't really feasible or likely that we'd be able to do that anyway. And a second large reason why we tend to use samples is that it's just not cost effective. There would be no way to spend the money that it would take necessary to conduct a study looking at all high school students within the U.S. So what do we do then? Well, this is where statistics come in and why you are taking this course. So when we talk about our particular sample that we have drawn from the population, inferential statistics are what allow us to have a sample and then make some kind of inference about the population. So when we talk about inferential statistics, we're really in general describing the whole population, what we believe to be true about the whole population from what we infer from the sample. On the other hand, there is another set of statistics called descriptive statistics that simply paint a picture of the sample. And when we talk about descriptive statistics, we are only talking about those things related to our sample. There is no inference to the population. There is no desire to even make a comment about the population. It's just simply looking at the sample. And we'll talk more about that as we go along. Another very, very, very important concept is this idea of sampling variability and error. Okay? And basically, as you see the definition here, it's the expected differences, most importantly, random differences that we expect if we were to take different samples from the same population. So for instance, let's talk about all high school seniors and their ACT scores. Okay, if I were to go and just pull out 100 seniors from across the U.S., find their ACT score, and take an average of their ACT score. Okay, so I could take sample 1, and let's say we pull out those 100 students, we average their ACT score, we might come up with something like 19.4. Okay, that is the average ACT score for our first sample. Okay, let's say we put all those 100 students' names back into the population pool, and we want to draw another set of 100 students from the population of all seniors across the U.S. We draw that 100 students, we take the average of their ACT scores, and we're going to get some other score for the second sample. And let's say this time we end up with 18.6. Now the question is, why do we have a 19.4 with one sample and an 18.6 with the second sample? Why the difference? Well, here's what we generally know. If we draw one sample from the population, the chances of it being identical to the second population is almost nil. While theoretically it is possible, practically and generally speaking, we're not going to draw the same average from both samples. The question we want to know then is this difference meaningful, or is this just simple random variance or sampling variability? Okay? Is this due to sampling variability? For our example, where we have a program to try to help ACT scores, we want to be able to say that no, this difference is due to our program, it's not just sampling variability. But in order to make that claim, we have to understand that this difference, these sample mean differences, exist just randomly when we take them from the population. We'll talk about this more, but just know from one sample to another, there is a difference that we expect just due from random error or random sampling variability. Okay? The next thing I want you to be aware of is just basically how we sample within the social sciences. There are two, I guess, dominant types that we need to be familiar with, though there are certainly many more than this, as you probably have already talked about in some of your other classes. But one of those is random sampling, and this really is the ideal. It's the king, if you will, or the gold standard. It's basically the idea that every person or object has an equal chance of being selected from the population. And as I said, this is the ideal, but it's not always possible, and if possible, it's not always really desired or maybe cost-effective as well. So what we often end up with in academia is this idea of convenience sampling. And as we talk further, we'll look at how this impacts some of our research findings. But convenience sampling is basically just using those students you have on hand, or those participants you have on hand that represent the population. So again, think about our high school seniors. Some of you who teach in secondary schools, you're probably not going to be able to get a sample of all high school seniors from across the U.S., so it's easier to just take a sample of those students you do have access to in your school. And you might take a sample and get their mean, and then using statistical concepts or inferential statistics, we're going to make some kind of statement about all seniors across the U.S. And we'll talk about more what this might mean for what we can really say about research, but just know random sampling, convenience sampling, two of the big ones, and convenience sampling in a lot of research is more what people use. Okay, the other thing I want you to be familiar with is the idea of a variable. It's a thing or event in nature that can take on different values. So again, think about our ACT scores. They can range, I think, from 2 to 35. I don't even remember now, it's been so long. But it's this thing that can range in scores from the low end to the high end. We talk about that in terms of variables. Now, hopefully, you guys have covered in your foundations course and other places the 4 different types of variables that we tend to deal with in social science, and that is nominal, ordinal, interval, and ratio. Okay, so we will often call this NOIR, representing the first letter of each of those. So NOIR, nominal, ordinal, interval, ratio. Nominal variables, basically here, are just categorical variables. So for instance, gender. It's just a category, male and female, and we might assign them values. We might assign males a 0 and females a 1. Okay. Ordinal, on the other hand, are things like rank. Okay, so if you imagine people finishing a race, instead of recording their times, you record their place finishes. Individual 1 placed first, individual 2 placed second, and so on and so forth. It's basically just a ranking of the individuals. With interval and ratio data, however, we're talking a little bit more complex type data. With interval, we're talking about things like, let's say, IQ, where there is a set interval in between. So with IQ, we may have a person with an IQ of 100 and then an IQ of 101. There is an interval there that is equal distance between 100 and 101 as it is between 101 and 102, okay? Which is very similar to ratio data. Except that with ratio data, typically what we say is that ratio data has a theoretically or an absolute 0, okay? So one of the ways we tend to look at this is with temperature. We would say that Fahrenheit and Celsius, okay, are interval scales because there is no absolute 0 on those scales. You can have a 0 degree Fahrenheit, but you can still go below 0. However, if we looked at degrees in Kelvin, we would consider that more of a ratio scale, because when you get to 0 degrees Kelvin, that is the absence of all heat, okay? So another type of ratio scale might be weight. You can weigh 0, theoretically. You can't weigh less than 0. And you can go up to as high as, well, as high as, theoretically anyway, you can go up to infinity. Though certainly you're not going to live long enough to hit more than, several hundred pounds. Okay? The last thing I want you to be familiar with as far as basic concepts goes is the idea of measurement, at least for the social sciences. And basically this is the assignment of numbers to objects or events according to some rule. Okay? If we talk about gender, we can, quote, measure gender for research purposes by creating a rule and assigning numbers based on that rule. So for instance, I can create a rule and say all males are coded 0, all females are coded 1. As long as then I code all males 0 and all females 1, I am, for the sake of social sciences, conducting measurement. Now, some of you may be saying, that doesn't sound like measurement to me, and this is where I sort of take exception with what we do in the social sciences. And we'll talk about this more face-to-face when we get there. But let me say this, that back in the late 30s, early 40s, there was sort of this challenge on the part of hard scientists to say, hey, listen, you guys in the social sciences, what you're doing is not measurement. And so there was a man by the name of S.S. Stevens who decided he was going to take up the gauntlet and he was going to prove that we were doing measurement. In the end, he could not prove, based on these tenets of the hard sciences, that we were doing measurement. And this is when, in his stroke of genius, he came up with this nominal ordinal interval ratio scale, in essence, to give us this new concept of measurement. Now, the question I sort of have for you guys, and I tend to always ask this, is if I were to measure the temperature of this marker based on this kind of definition of measurement, I might hand it to 3 or 4 of you and ask you to give me on a scale of 1 to 10, what is the temperature of this marker? Some of you might say 2, some of you might say 3 or 4 or 5, but in either case it's a very imprecise measurement, if you could call it measurement at all. We could take our average and come up with our quant class temperature scale. That is very different than what we see with Fahrenheit, Celsius, and Kelvin. So the question is, really what are we measuring in social science? And we'll talk about that a little more once we get into the face-to-face.